The topic for Lesson 5.5 is inequalities involving two triangles. We'll learn how to apply the side angle side inequality and the side inequality. Many objects, like a backhoe, have two fixed arms connected by a joint or hinge. This allows the angle between the arms to increase and decrease. As the angle changes, the distance between the endpoints of the arms changes as well. Theorem 513 states, if two sides of a triangle are congruent to two sides of another triangle, and the included angle in one triangle has a greater measure than the included angle in the other, then the third side of the first triangle is longer than the third side of the second triangle. So in this example, AB is congruent to PQ, and AC is congruent to PR. If the measure of angle 1 is greater than the measure of angle 2, then BC must be greater in length than QR. Theorem 514 is a side inequality theorem. If two sides of a triangle are congruent to two sides of another triangle, and the third side in one triangle is longer than the third side in the other, then the angle between the pair of congruent sides of the first triangle is greater than the corresponding angle in the second. So, looking at our diagram, if AB is congruent to PQ, and AC is congruent to PR, and if BC is greater in length than QR, then the measure of angle 1 must be greater than the measure of angle 2. Here once again, we're kind of skipping to the solve number type things and letting the proofs be. So they ask us to write an inequality using the information in the figure. Compare the measure of angle WYX and the measure of angle ZYW. And I just marked that with 2 just so we could see it, not saying that it's bigger, because in fact it's not. Side WY is a shared side. We don't know what it is, but it has to be the same as itself. And ZY and XY are both 8. So that means that we've got our side angle side scenario going on. So the angle with the larger side opposite must be the larger angle. So in this case, it'd be WYX. So the measure of angle WYX is greater than the measure of angle ZYW. For part B, they ask us to find the range of values containing n. We just said that the measure of angle WYX, which is our 7n plus 5, is greater than the measure of angle ZYW, which is 47. So we can subtract 5 from both sides and divide by 7. So n must be greater than 6. And we know that we can't have negative angle measures. Well, not in a triangle. That would be odd. So we can write another inequality that says 7n plus 5 must be greater than, can't equal 0, just greater than 0. So we'd subtract 5 from both sides. So 7n is greater than negative 5, divide by 7. So n must be greater than 5/7. Well, that was not entirely helpful because we already know n is greater than 6. Okay, so let's leave that over here for now. We also know that an angle of a triangle can't be bigger than 180. So let's try that equation. 7n plus 5 is less than 180. Subtract 5. 7n is less than 175. Divide by 7. N must be less than 25. All right, that makes more sense. So n has to be greater than 6. So here's 6 on the number line. And less than 25. So this is a nice betweenness statement. We didn't have to draw the number line, it just helps so that you can see how the betweenness bit is working. So we would write that as n is between 6 and 25. So n has to be bigger than 6 and less than 25. We weren't off when we said n was greater than 5/7 because we already knew that when it had to be greater than 6. Sample 3A, write an inequality comparing the measure of angle LDM and the measure of angle MDN. I just marked that with different marks to tell them apart, so we're seeing where we're looking. They both have a side that is 12, and they both share side MD. But I am pretty confident that 18 is more than 16, so that means that angle LDM must be the greater angle. Now they want us to write an inequality, finding the range of values containing A using the information in the figure. Okay, from part A, we said that measure of angle LDM, which is 141, is greater than the measure of angle MDN, which is our 9A plus 15. So let's solve that for A. So we have 9A is less than, that's a lousy A. 141 minus 15 would be 126. Divide by 9. So we have 14 is greater than A. And then again, an angle cannot be, measure cannot be negative, so 9A plus 15 must be greater than 0. Divide by 9. A is greater than negative, reduced by 3, 5/3. If I rewrote my first one, that would have been A is less than 14. That looks nicer. So now we have both a less than and a greater than. I'm happy. So I can start with the negative 5/3. A has to be greater than that, and it has to be less than 14. Doctors use a straight leg raising test to determine the amount of pain felt in a person's back. The patient lies flat on the examining table, and the doctor raises each leg until the patient experiences pain in the back area. Naitan can tolerate the doctor raising his right leg 35 degrees and his left leg 65 degrees from the table. Which foot can Naitan raise higher above the table? Would be the one with the bigger angle, his left leg. In summary, we looked at the angle-side inequality in two triangles. If two sides are congruent, then the measure of the included angle determines which triangle has a longer third side. And the side-side-side inequality in two triangles, if two sides are congruent, then the length of the third side determines which triangle has the included angle with the greater measure.